Welcome to the course Digital Transformation and Technological Innovation. So, we are into our third module, that is transitions in software markets. So, let us continue our discussion that we have had in last few sessions. So, next firm. So, what are the top OSS firms and what kind of products that they are having? So, one of the top OSS firm is Databricks, right, and this is into a unified data and AI platform which is built on top of Apache Spark, right. So, it is into big data and AI space and doing quite well, and that is why we have listed it first in our list of top OSS firms. Next one in our list is MongoDB. So, MongoDB we have earlier also talked about when we talked about JavaScript based stacks and we talked about MERN and MAVN and other variants, and MongoDB was one of the part of that stack and filling the gap for database, right. So, actually this is a NoSQL database provider. So, MongoDB a leading NoSQL database provider, and they also run their own managed Atlas service. So, through that they generate their revenues. So, MongoDB is another top OSS firm and doing quite well because of their Atlas service, managed Atlas service. Then Red Hat is there, like we talked about earlier also. This is considered one of the most significant open source firm. Rather OSS firm, when they started looking for revenue stream, Red Hat was one of those firms which actually could generate revenues by providing ongoing support and services for open source products. So, it was acquired by IBM for $34 billion in 2019. So, these numbers are also telling us a story about the valuation of Databricks or MongoDB, so which are much higher than the kind of number that we see for the Red Hat in 2019. Then after these three top OSS firms, we have few more, for example Anysphere or Cursor. So, some of these firms are new, but they are doing quite well. So, a newer AI native code editor they have come up with, and it is seeing explosive growth, especially in the developer tool space. So, the AI native code editor, right, Anysphere or Cursor. So, this is another firm. Then HashiCorp is another firm. So, this is known for is infrastructure as a code software. Now, we have spoken about cloud and how firms can go for cloud computing services instead of on-premise services. We will talk about that more, but HashiCorp is also in that space providing infrastructure as a code software tool, Terraform. So, name of their product is Terraform. So, what it does, it allows configuration of cloud and on-premises infrastructure across a provider. So, that means one can manage all their computing through this infrastructure as a code tool, whether it is about cloud workload or non-cloud workloads. So, those can be managed through this. So, this is another level of transformation that can be facilitated by HashiCorp's Terraform, right. So, this is another important firm. Then Mistral AI is there. This is also one of the top OSS firm. So, this is focusing on high performance open source generative AI tools. So, in this slide itself we can see one open source OSS AI firm, that is Anysphere with the AI native code editor and Mistral AI with the open source generative AI model. Then there are other important firms, for example Vercel is there. So, this is the firm or the platform behind the Next.js framework, that is one of the modern framework. We earlier also a little bit included that in one of the stacks. So, a platform behind the popular Next.js framework facilitating front end deployment. So, this is another firm that is doing well. Then GitLab. So, GitLab we have already spoken about. So, this is a complete DevOps platform like we discussed earlier, competes with GitHub, which is now acquired by Microsoft, and maintaining a high transparent open source model. So, it is still an open source firm, while GitHub was acquired by GitHub was open source, got acquired, and now part of Microsoft. Hugging Face is another example that is a central hub for open source machine learning models and data sets. So this is another firm that is doing quite well, mostly in AI and machine learning space. So these are the examples of top Oasis firm, and what we have discussed, why these firms are doing well, all those things that we have earlier discussed in previous session. These firms present the examples of that success story. So now we move to our next important question, that why is Linux not a major player in the PC segment? While we talked about so many success stories for Oasis firms, let's take one of those cases where it has not worked well. So for example, Linux not being a major player in PC segment. While we all understand success of Linux in so many other handheld devices, smartphones, and many appliances, right? Embedded operating system we already talked about. So everywhere Linux can be seen everywhere, but not in PC segment. So what are the reasons for that? So one is a steep learning curve. So the Linux operating system, which is typically used for PC segment, that also has a steep learning curve in terms of installation and uses compared to Windows and Mac OS. So Windows and Mac OS, they actually have much lower learning curve, and that is giving them the advantage. Then another maybe even bigger problem is that Linux doesn't have Android level user centric design, right? So when Google started with their Android project, then they had to cut down the Linux code a lot and come up with this integrated operating system which has a very nice user centric design. So they had to hide many things, many complexity under the hood, right, to be able to come up with the Android, which is actually a Linux variant, lightweight Linux variant, right. So Linux for PC segment could not achieve that, could not come up with user centric design, right, and therefore the learning curve remained steep enough, and adoption could not happen. So now Linux complexity also another reason is that because the complexity could not be lowered, or Android kind of thing could not be done. So the steep learning curve remain, and therefore the total cost of ownership for end users goes up, right. To be able to manage a Linux operating system, the kind of cost that would be incurred for an end user, that is higher. Now what is total cost of ownership as such, that we will talk about, because this is also a different economic concept, in the sense in comparison to the physical products. Total cost of ownership, the moment we use this term, this mainly applies in the IT segment, in the software products, and we will talk about details of this. So complexity of Linux that raises the total cost of ownership, and therefore that option goes down. And then how it raises the cost, there become this need for continuous end user support, that will always be there, because there is always a good chance that you might end up doing something with the Linux OS in your PC, that you might have to take some support, and that support will also come up with its own cost and productivity loss and all that. So any savings that might come because of Linux being free, that would be easily offset because of the need for continuous end user support. So you need people who would help end users managing their Linux, because of the complexity, the learning curve, and many other things, right. Now because of all these reasons, another important factor that adds to the problem of Linux in PC segment is limited application availability compared to Windows and Mac ecosystem. So Windows and Mac system, one of the reasons they became popular, because they could amass a huge user base, and they could attract application developers to write applications for these operating system users. So because of the good user base, they could amass, many developers would be willing to port their applications for Windows and Mac. But this could not happen for Linux, because users were not able to adopt to it because of the steep learning curve and the complexity and all that. So another added reason for lack of success for Linux in PC segment was limited application availability. So lots of applications have not been ported to Linux. Now why users buy a computer or buy a PC or laptop? Because they need some computing, some software that they need to use for their professional or employment related work or other work, individual work, and for that application should be available, right, should be supported, should be working quite well on a particular PC and including operating system. So this is smaller PC user base, this is not able to pull application developers to port their applications. So number of applications availability or the application ecosystem for Linux in the PC space remained much lower. Then lack of unified Linux platform. Now there are so many variants for Linux. That means if application developers they are porting an application for Linux, they would be porting it to a particular Linux variant, and therefore for all other Linux they might have to do a little bit changes, maybe not much, but still because the Linux operating system is quite fragmented in the PC space. So lack of unified Linux platform. This is the gap that was actually filled by Android. When Google started promoting Android, so that Android became the unified platform for smartphone OS, and therefore fragmentation was taken away, and that eased out the market for Android, and it became a success in the smartphone. So many regions worked for Android, and but some of those things were actually could not happen for Linux. So lack of unified Linux platform, fragmentation makes it difficult for developers to build apps, right. Now we talked about the total cost of ownership, and we, I said that this is slightly different from what we see in terms of total cost of a physical product, right. So when we talk about total cost of a physical product, the raw material, labor cost, all those things, a bit of overhead, and maybe those kind of heads would go in terms of forming the cost, total cost for a physical product. But when it comes to information goods, information product, especially software products and computer hardware products, so we typically use total cost of ownership. So what is this about? This is an economic measure to calculate the full cost of owning an IT product, be it a computer hardware or software, or for that matter in general information good, right. So there are direct cost, right, which is like purchase price. So this will actually be subsuming everything that goes along with the development, testing and all that. So all that cost added up, and then there would be a price tag after adding the margin and other things. So the moment we say purchase price, so that is more like a direct cost. If the company itself is developing the software, then they will be doing development costs, testing and other things that would be there. So this is the direct cost. So this is quite comparable to a physical product, but there are indirect costs, for example training, support and maintenance, right. So that in computer hardware or software might need continuous upgrade also, maintenance. So all that will go into maintenance, version, new versions will come up, you have to do installation and all that. Support, if there is any problem with the software, it might crash and it might get corrupted, or there might be some issue, and then again support would be needed. Training to be able to use that software effectively or use that hardware effectively, so the training would be needed. So training, support, there are lots of small components that would be part of training, support and maintenance. So these indirect costs add up in case of information goods, software products and computer hardware products, which is not the case with the physical products. So therefore this concept is important in terms of differentiation, that total cost of ownership is actually different for these products, and in case of Linux, right, this goes up because of the added complexity. So therefore more difficulty in terms of maintenance, support and other things, and training also. So steep learning curve, so therefore more training might be needed, or more in-depth training might be needed. So therefore indirect cost goes up and total cost of ownership goes up for Linux. Now moving on, what are the different categories of cloud computing? So cloud computing we have talked about earlier also, and sometimes we refer to the term SaaS or software as a service. Now we are doing this differentiation in terms of different categories of cloud computing in more detail, right. So first up is software as a service or SaaS, right. So software as a service is also is one of the main cloud computing service, and it delivers online access to off the shelf software. This off the shelf software could be OSS product, could be a proprietary commercial offering, right. So online, so this software as a service delivers online access to off the shelf software to firms or end users on subscription plan, right. People want to use a particular software, let's say Salesforce, and that also has a SaaS offering option. So it is being used by companies like Uber and Spotify to manage their customer relationships and sales pipelines, right. So Salesforce would be providing that their Salesforce CRM product via cloud, right. So it would be a SaaS offering, and it would be based on some subscription plan, right. Already companies like Uber and Spotify are using this. Similarly, another example is Slack. So this also is a SaaS offering, so used by companies like Target for real-time collaboration across their retail operations, right. So this is again another example where a company like Target is using a SaaS version of the software. So what is the before the cloud computing service, you will have to install the software in so many different locations and computers in those locations, and manage the maintenance and everything, all those things that go by with it, right. So all that is taken away by cloud computing services, right, and the delivery is online. And if you are a firm which is looking for looking to use a OSS software, right, OSS product or a proprietary commercial, and don't want to worry about managing upgrading, versioning, maintenance, the computing that is needed and other things that is needed, then you are just better off with the SaaS offering for that particular software. Now what are the revenue models for SaaS, how the pricing happens and how the revenue is generated for SaaS products or SaaS offerings. So this is mainly designed, so revenue models are designed for predictability, because the target segment would be non-tech firms and the end users in those firms. So easy budgeting of options, so that there is a predictability in budgeting, right, so that firms can plan for budgeting of this SaaS, and therefore revenue models have been formulated in that way. So let's look at what are these revenue models for SaaS. So first one is freemium. So this is important for attracting users, because your software or SaaS offering is quite good. There has to be word of mouth for that, for a company to make sale on that. So therefore a freemium revenue model makes sense. This is a free basic version that is given to end users, and if they want to use advanced feature, then they'll have to pay. So example, Dropbox. So if you open a free account, freemium account, then you will get about 2 GB of cloud space to keep your files there in the cloud and collaborate and share and work in a team. But if you want to use more than 2 GB space, then you will have to subscribe for a premium version, right. So you will have to pay for the charges for the advanced features. You will have to switch from freemium to some other revenue model, other plan, right. So this is first one. Then per user or seat based revenue model. So this is more like fixed monthly fee for each user who has an account. So depending on how many accounts that you want, that much you will have to pay. For example, Slack and Salesforce, they actually have this as an option for their SaaS offering. So per user or per account or seat based kind of revenue generation or kind of pricing, fixed monthly fee. Then tiered or feature based revenue model. So what happens here, the packages, different plans or packages that are there, they are graded into different plans like basic, pro and enterprise. So basic will have simpler feature, it might just be the freemium version, and then there is a pro where additional advanced feature would be there. Then enterprise is there, then more advanced feature, more people can work with that account, right. So more features are unlocked at higher prices. As you move from basic to pro to enterprise, it's more like a graded thing, and therefore more advanced features would be unlocked at higher prices. So companies like Zoom, HubSpot, so they are using tiered revenue models, feature based revenue models. So overall, if we look at for the SaaS, which are the common revenue model, one is freemium, then per user or seat based, and then tiered, which is feature based. Then we come to our next category of cloud computing. So first one was software as a service, right, which gives online access to off the shelf software. Now next is utility computing, and with the utility computing we have two variants: platform as a service and infrastructure as a service, right. So what is utility computing and its variants? So this is also a cloud computing service that delivers access to computing resources to firms for running their own software or custom software or computing on the cloud, right. So this is again more often than not is going to be usage based plans, right. So there are two variants: platform and infrastructure as a service, platform as a service and infrastructure as a service. So let's talk about each one of them. So let's first talk about platform as a service or PaaS. So this is a cloud computing service that delivers online access to a software platform to firms to develop, test and deploy their own custom software on the cloud. So if a firm is not looking to just take online access to a off the shelf offering, and if they want to develop their own or they want to customize their own version from open source offering, right, but they want to host that on cloud, or they don't want to have on-prem computing for development of their software or hosting of their software, then they can go for platform as a service, where they can simply take the software platform with the required set of tools in terms of operating system, database if they need it, ID software for development, testing and deployment software for testing it out and then deploying it for finally, right. So they can subscribe to or takes services, these kind of PaaS kind of cloud computing services, where they can take online access to software platform with some of these options like database and other things, and then customize their own software, develop their own software and host it, right. So the idea is, if as a firm you are not using off the shelf software, then you can go for platform as a service and develop or customize or configure your own and host it on the cloud. Now what are the example of platform as a service, right. So here we had already covered the examples. So going back, so what are the examples of platform as a service? So Amazon DynamoDB, so this is a NoSQL database. So there is a PaaS offering is available for this NoSQL database. So there might be some firms which might want to customize their application, which is database oriented application, and they might want to take Amazon's DynamoDB this as a platform and build their application on top of that, right. So this is for NoSQL database and used by, for example, Netflix to manage its massive scalable application data, right. So there are so many movies, series and many other items that Netflix is hosting in their app or website. So this NoSQL database, there are so many things not relational in the kind of items that they are storing, right. So this database solution is suitable for them. So Netflix has taken that from Amazon. So this becomes a platform as a service, where Amazon as a cloud service provider or PaaS vendor, they are providing database solution, and Netflix is building their application on top of that. Then another example is Amazon RDS. Now this is SQL database. This is a relational database. This DynamoDB was NoSQL, RDS is SQL, right. So this is used by Airbnb to handle administrative tasks like scaling and backups automatically. So there would be a lot more inventory for Airbnb to display in their website for renting and other other alternatives. So they have taken PaaS offerings of Amazon, in particular RDS, right. So these are example of platform as a service. Now if we look at the revenue models for PaaS, then revenue models for PaaS, they actually lie between fixed subscription that we earlier talked about in case of SaaS and raw usage, because here a platform is being given. So database solution might be used as needed. So therefore raw usage comes in. So the plans or revenue models are more likely to lie between fixed subscription and raw usage, right. So more likely it would be like a base fee for taking the PaaS offering plus charges for resources consumed, right. And the base fee is more like a platform fee, and then consumption based charges or usage based charges, right. Now first model itself is there for resource consumption. So in this revenue model, charges are based on the number of instances, CPU hours or memory that has been consumed. For example, Google App Engine. So Google charges their clients, right, based on this number of instances, CPU hours and memory. So first model is resource consumption, then second is API based. So in this case, charges are actually triggered by specific action. So whenever you interact with the API, the actions are triggered, and therefore charges will also be there. Actions like what? Such as number of messages sent or API calls made. For example, Twilio or Stripe, right. So you want to send messages through Twilio's platform as a service. So API, you are interacting with their API. So in a way their system is getting used, and based on the number of messages that you are sending, you will be charged. So essentially it becomes raw usage kind of scenario in the case of API, right. So there is an API based model. Similarly for Stripe in case of payment, right. So then there is another revenue model, per developer seat, right. So here the charges are based on the number of developers using the environment to build apps, right. So if there are a lot more development that is happening, so many people are collaborating. So to be able to support that collaboration also this might be needed. So number of developers, depending on that, those many accounts would be needed, and therefore per developer seat charging can be based on that, right. So these are some of the common revenue models for PaaS offerings: resource consumption like Google App Engine, then API based, for example Twilio and Stripe, and then the per developer seat. Next is infrastructure as a service. So infrastructure as a service, this is also under utility computing. So here the cloud computing service delivers online service to raw computing infrastructure. So earlier we still talked about a software platform which could be a database, which could be an API or some app engine. Now here we are not even saying that. We are saying raw computing infrastructure. So essentially we are meaning computing, storage and networking. So it's like buying computing and storage and networking. We take that through a cloud vendor, through their infrastructure as a service offering, IaaS offerings, right. So IaaS offering is in a way gives an alternative to buying computing resources. So you want to control computing resources the way you would do in a on-prem setting, right. But you don't want to buy and get them in on-prem. Then the alternative is infrastructure as a service. So you will be allocated computing, storage, networking, and you can control as per your preferences, right. So you can control them as per your preferences. So firms can manage and customize their computing on the cloud based on their own software and system preferences. Firms can take IaaS service and decide what kind of operating system they want to have there, whether they would like to install their own IDE or own other tools, and customize the kind of computing environment that they need. So infrastructure as a service facilitates that. Then next up is what are the examples of this. So Amazon EC2 virtual servers, these are actually being used by Netflix, and Netflix is running its entire backend video transcoding and data analytics, all that goes by it. So essentially they are taking virtual server. So essentially the raw computing they are taking, and they are running the whole backend and everything with that. Similarly, Airbnb, they are also taking EC2 instances, and what they are using it for their searching component, right. Similarly, they are taking Airbnb is taking Amazon S3 and using it to store user uploaded property pictures and all that, right. So these are here, this is example of storage, these two examples of computing. So whether it is computing, storage, or networking, these kind of things could be taken as through infrastructure as a service offering by these cloud vendors. So let's stop here, and we'll continue our discussion on this in the next session. Thank you.